All right, here we go. Happy Friday. Today is day 3, and what I want to do today is go over the notes that you guys should have copied yesterday and the 2 practice problems that you should have been able to do yesterday as well. So today we're looking at types 2 and 3. They're really similar to each other. They're called incomplete and codominant problems. So the other day you guys learned about monohybrid crosses, which means that you cross one trait, and within that one trait you had one allele that was stronger than the other, one gene that was stronger than the other. So because of that, we had dominant and we had recessive. We had capital case letters and we had lowercase letters. In these 2 problems that you guys are going to see, neither allele is dominant over the other allele. Neither trait is dominant over the other. And because of this, you're going to get a different or a mixture or blended phenotype, meaning you're going to get a third choice here. So my first type of problem is that incomplete dominance problem. Here, the phenotype of the heterozygous, meaning my 2 choices, when I blend them together, it's going to be just that. We're going to see a blending of them. So, for example, in Snapdragon flowers, and I believe you guys should see an example of them within that PowerPoint that I posted yesterday as well. When we take red flowers and white flowers, when I put them together, my blended effect, my mixture of the 2 red and white, is going to give me pink. So what that means is that red is not dominant over white. White is not dominant over red. I don't have a recessive choice. It's not like, oh, pink is recessive. It's not. It means they're all kind of seen at the same strength. And when I blend the 2 of them together, it's going to give me that mixture of pink, that blended of pink. There are 2 ways that you guys can do these problems, meaning how you write your key. The first way is with that little symbol there, which is my prime symbol. So this is where I'm using one letter. I don't want to use a lowercase form of that letter. So what I'm going to do is I can say red is RR, white is R prime, but when I blend them together, this parent's going to give one of those alleles, this parent will give allele. I have R prime as my pink. Does it matter who's the R prime? No, I could have made red R prime. I could have made white RR. And down here, it doesn't matter which one goes first. Neither's stronger than the other, so I could have put R prime R. Just keep it consistent. Whenever you put in your key, put it the same way throughout the problems in your genotypes as well as your phenotypes. The second way that we can do this is using 2 different letters. Remember, I don't want to use a lowercase of the letter, but I can use 2 different letters here. So I can say red is RR, white is WW, pink, when I put them together, R here, W here. My mixture of the 2 is RW. Okay, it doesn't matter which letter goes first. If I want a WR, that's the same thing. It's just as well. All your steps are going to be the same. If I want to cross 2 pink flowers now, still going to show my key. So key, my 3 choices. I have red flowers, I have white flowers, I have pink flowers. I put both of them within the key. You absolutely do not have to do that. So if I'm looking at it and I have red flowers, I can say red is RR, white is R prime, pink is R prime. Or you can use the 2 different letters. That's fine with me. Red, RR, white, WW, pink, RW. But know that if you see those primes somewhere, what does it represent? What are we looking at? What are we doing with it? So my parents, I'm crossing 2 pink flowers. Go back to your key. RW, RW, I do my Punnett square. 1 parent across the top, 1 parent down the side. My possible F1 offsprings are in the middle here. Genotypically, RR, RW, WW. So I have a 1 to 2 to 1 ratio. And now when we do phenotypes, we have 3 choices again, unlike the 2 that we had with our monohybrid crosses. I still have red, pink, and white. So I still have a 1 to 2 to 1 ratio when you go back and look at your key. If I had asked you guys to do an F2 generation from this, you would actually cross 2 of your F1s. And if they were all a little different, you could pick which ones you want to do. You would go, oh, maybe I want to cross RR with WW. Or maybe I want to cross RR with RW. By doing that, you're creating that second generation. It's kind of what Mendel did with his pea plants. If we go ahead and we look at the next type of problem. Our next problem is what's known as codominance. So with my codominance, it's very similar to incomplete, but instead of getting a blended effect, I'm going to see both of them at the same time, and it's going to give me a completely different phenotype. So for instance, if I take red cows, and they're not really red, they're kind of like a bricky brown color to them. If I take red cows and white cows, I'm not going to make pink cows. I actually make something known as roan cows. And these roan cows are kind of red with white spots to them. And you guys should see a picture of them in the PowerPoint that I put there yesterday as well. So if you didn't go through that PowerPoint, go through. Give you guys some good examples of the difference between these two, because you do need to know that one is blended and one, your codominance, is showing both phenotypes at the same time. So the keys can be written the same way that we just did our incomplete dominance. So we're either using the primes or we're using two different letters. So if I'm looking at those cows again, I could say red, white, and roan are my three choices for my key. Once again, you can either use the primes or you can use your two different letters. I'm going to go with the two different letters here with the rest of the problem. So I can say red is RR, white is WW. When I put them together, RW, that gives me that roan, that red with white spots to them. I'm going to cross two roan cows, RW with RW. One down the side, one across the top. Possible F1 offspring. Genotypic ratio, step 4. Show me all 4 steps. Kind of circle them so that I can follow through with you guys. I have 1 RR, I have 2 RW, I have 1 WW. Phenotypically, I can produce 1 red, 2 roan, and 1 white cow. So you would go, oh, well, how could you ask me questions on a test? Because the test would be multiple choice. I might ask you to do a problem like this. You might do it on a piece of scrap paper that you have there, and I might say, what percentage of the cows could be white? You would go, oh, they have a 25% chance of having a white cow. What are the chances of having a roan cow? 50%. And you guys may see questions like that along the way. Okay. I'd ask you guys to complete the 2 practice problems on the next page. If you have yet to do that, please do that now. We'll be back in a moment and I'll kind of go through those 2 problems for you guys.